Hi all of you, good morning. Online students, are you able to view the screen fine? All is good online? Vidhi, Ganesh, Anuba, good morning, good morning. Jatin, some of you don't interact at all, so I do not know you by your names either. I have not interacted with Jatin. I think Vidhi we have. Hello Mani, good morning. Good morning. Okay, very nice. Okay, fine. So, right then we start off. Yesterday we had a disruption, couldn't finish the topic we are supposed to discuss. And there was a bit of outage. In fact, even today we are told that there will be another outage today also. I think the winters, people tend to consume more power, heater and all of that. So the ORN transformer keeps conking off. So let's see, let's hope for the best. I'm told that maybe around 11 o'clock probably. Hi Abhishek, good morning. Good morning Abhinav, good morning. Okay, let's get started in that case. From where I left. So quickly revise what we talked yesterday, but can I assume you're all done your summary work? Yes? So keep it as a habit. Online students, are you doing your summarizations every day? We started yesterday. Okay. Did you manage the summarization work, online students? And we'll share the link with you where all of you must also submit. Don't just do your work and keep quiet. You need to let us know you are doing. So it's like a habit thing, okay? It's like a habit thing. In a habit thing, you do your work, and you also declare that. Okay. And then what happens is this falls into some type of consistency. If you keep doing your work and you keep quiet about it, there are times when you will slip. एक आध दिन मन नहीं करेगा नहीं करने के लिए. Okay. Shreyas, the summary work is the compilation, the consolidation rather, of the day's work. Generally, when I am taking classes, I'll teach you approximately 10 to 15 pages of writing on a daily basis होगा आपका. These 10 to 15 pages, yeah, good morning, 10-15 pages you must compress into one page. Compress into one page. So we talk about compression by writing small. You can compress by focusing only on the keywords. You compress by using diagrams and pictorial tools, and you compress by using all a space of your page. कोई भी पेज का जगह छोड़ना मत. Okay, keep it very very tack. Yes Debarga, all of this will happen. Okay, I'm just starting off. That's why I've not activated your tab for upload, and somebody will come and help you also for the new students how to do that. So it's like it's a saying in English, a word at hand, okay, a bird at hand is worth two in the bush, which basically means whatever you have at hand, that is far more valuable than what is out there. So what happens is we tend to get complacent about what we have. We take it for granted, and we are constantly looking out for कि और क्या मिल जाएगा और क्या मिल जाएगा. The same thing will happen with the studies also. So there is a class work going on, and that there is material, there is information, there are books out there. Okay, ये market में है, किताबों में है, which you have not read. Your friends can have some material. So what we do is we tend to neglect this. क्या यह तो notes में आ चुका, and we keep running after this. My strategy is ये जब होगा देखा जाएगा. We'll do something here. But whatever we do in class, you try to consolidate that. Okay, and slowly, gradually, we will inch into this also. Okay, I will not let go of this additional work also, but slowly, gradually. So your work is whatever we do in the class, you have to consolidate, and the form of consolidation is that you have to make a summary. Like everyday basis, this is a daily work. Any class you attend, whether it is GS or it is current affairs or it is your optional, whatever class you do, convert that into a summary, which I call as synopsis. Okay, some kind of a summary, cheat sheets. Shreya, I'm addressing you, but all the others also I must remind. So your class, so if you're looking at your class consolidation, okay, it involves, number one is attend the class, followed by, okay, make your notes in the class. Okay, don't just listen. Okay, many of us, we sit quietly and keep listening to what is taught. वो पढ़ाई नहीं है. You have to write down. This entails writing. Okay, and third work is you have to summarize. You must summarize the work. And the fourth work is you memorize the synopsis. जब ये चार काम हो जाएगा, then your class work is done. Okay, so अभी आप क्या कर रहे हैं? You are attending the class, and I'm making sure you also write the notes. I'm dictating, I'm asking you, I write on the board. The reason why I write on the board is because you can keep pace with whatever terms I'm saying. तो आप ये दो काम कर रहे हो, and I presume you'll do this. Now you must move towards summarization on a daily basis. Okay, so please, all of you, it's a reminder. It's my work every day morning. I will remind you this. I'll try to push you on and make sure that this is done at best. Best is if we can do it immediately after the class. Because if you are in class attentive, it's all fresh. आप भूलोगे नहीं. The moment you delay it, you will start forgetting and you will feel like यार कुछ और पढ़ लेते हैं. Okay. So do this, everybody. Okay, I presume all of you have done it. Synopsis, you walked in late, you have done it. I would like to see a synopsis on daily basis. Offline students, get your synopsis to class. Let me have a look, all of you. And others, okay, you will have to do on your own. But please do that. We have given that already. Okay, Satyam, the year-wise topic questions are given. If not uploaded, we'll do that. We have already given it to the offline students here. Okay, and the second work I told you is that you have to read the NCERT class 11. There are 6 chapters, chapter number 2 to chapter number 7. ये 6 chapter करना है. You can ignore the first chapter. Okay, Shreyas, I will ensure it's done. ठीक है? Yes. Submit, okay, Naveen. That I will take care. I'll take care, Naveen. This submissions, the ones who joined me earlier, आप लोगों ने कल दिया नहीं submissions. They bought it today. Very nice. Give it today if you have done it. Others, please submit on Saturday. You have got 1 week. I think that's good enough for time. Okay, submit on Saturday, chapter 2 and 7. I want the summaries of these chapters. Okay, let's get started then. That's the beginning. So yesterday's class, quickly, we have taken care of some details about the planets. We talked about some important features related to search for extraterrestrial life. terrestrial life. We're looking where is life possible in the universe beyond Earth. Yes, Ganesh, there was an outage yesterday on the app also. Okay, we will set it right, don't worry. Aap class kar lo. Okay, there are some updates going on. Not our fault actually, wo jo Microsoft ka hai. But we'll get it done. Please be patient on that. Okay, so planets we have done. You understand the planets, Mercury, Venus, Earth, Mars. Now, this is a very important topic for your study. Whatever we are doing to find out, I said, the importance of water for life, the importance of identifying the right temperature, okay, the importance of oxygen where possible, and linked to these concepts, I gave you 3 points. One is that the life forming matter, the life forming matter is distributed across the space. Even the comets, I talked about the tail of the comets. It has lot of ice crystals. So some chemical reactions has created that ice. Our universe has compounds, carbons, which ultimately will convert into oxygen. So जो life matter है वो distributed है. That's one discovery we found, and this is proven by the fact that Mercury also has ice on it. All this nearest to the sun, but there are parts which has ice, and maybe the comets have bought it. So that's one important thing. The second important thing that we discussed was what is the Goldilocks zone. It's also called as a circumstellar habitable zone. This is a orbital zone, एक orbital belt है around a star. Say if this is a star, around this star there is an orbital belt, okay, where the conditions are just right in terms of temperature, where this planet, यहाँ अगर कोई planet है, this planet can have life, and this habitable zone has been found in many exoplanets. I used the term exoplanet. So all the planets of our solar system, we understand, all the planets of the other solar systems, including those which are in the galaxies beyond Milky Way, we call those as exoplanets. So there are a lot of exoplanets where life is possible. We gave a number. There are more than 40 billion possibilities of where we can have life. Okay. So this is second point. And third point, a very important conclusion of recent times was that they are now searching for planetary atmosphere where the carbon dioxide content is less. Okay, it's something like what happened for Earth. There was a time Earth had lot of carbon dioxide because of hydrological processes and rainfall. The carbon dioxide has been washed down. There are hydrological cycles that force carbon dioxide to ultimately dissolve in the oceans. So if we have a planet which is in the Goldilocks zone and which has less carbon dioxide, this is a very good evidence of that life forming processes can operate. Okay, so these are some of the discoveries we talked about life. So, आप जब news भी देख रहे हो, any news around this is a possible question. Okay, that's one discussion we had. Then I was talking about stars, and I just mentioned the life cycle of a star. Okay, because a second very important study is to understand the origin of the universe and our solar system. So one objective of lot of studies is to find life on bodies beyond Earth, and the second objective of lot of these space missions is to understand the origin and the evolution of the space of universe of the solar system. And lot of these mysteries we know are hidden in some bodies called as black holes. So, बहुत सारी researches हैं, lot of missions are there, lot of observations are there around black holes. So, black holes, I said the topics is partly overlapping with science and technology, but I'm trying to give a perspective which is geographical perspective, okay, in terms of location, what happens. So, fine, it's all interdisciplinary here. So, talking about life cycle of stars, I said there is a cloud which is called as the nebula. The nebula undergoes accretion and it becomes a star, and the star can be an average star or a regular star. The average regular star ultimately can die off. It can become a red giant. Okay, a red giant. Not much of issues there. There are certain massive stars. These massive stars, they convert into two possible things. They become massive red giant, okay, and ultimately they can become what's called as the neutron star, or they can become a black hole. In fact, in दोनों में बहुत ज़्यादा difference नहीं. I explain 6-7 terms, okay, about how you can differentiate this. Before this, I must tell you some concepts more. Hi Shivangi, Abhinav, good morning. So I think यहीं पर ही हम लोगों ने छोड़ा था last time, and I was getting into one more concept called as TDE. Okay, that's where we got interrupted. I think no problem till here. Just know some terms. Okay. Online students, is it okay till here? Okay. All good? No problem till here? Okay. Now, आप सुन लो पहले. Then I will give you some notes. There is a concept called as TDE. TDE is tidal disruptive events. Okay. In space sciences and in astronomy, whenever you use or you hear the word tidal, the tidal means gravitational. Remember this. Whenever you hear this term tidal is about gravity. Okay. Earth's tidal pull, okay, tidal waves, tidal disruptions, they all are related to gravity. Okay. Yesterday I explained what is a black hole. So black hole essentially is a dead star. Okay, a dead star. So what do I mean by dead star? A star, I said, it has a fusion reactions going on, where hydrogen is rapidly converting into helium. Okay, and there are other elements also. Carbon bhi hoga, iron bhi hoga, a lot of other elements are there. So when the hydrogen to helium fusion reaction is over, okay, it becomes a dead one. Okay, so a dead star, and it has very high gravity. A dead star is not a star that has disintegrated. Nahi. A dead star is like, I have a ball which is very hot, it is burning, and the ball becomes cold. The ball ultimately becomes reddish and finally it dies down, but it remains a ball. The mass is still there. ऐसा नहीं है कि the black hole will disintegrate and explode. ऐसा नहीं होता है. So when I say a black hole, it is a dead star, very high gravity because it has very high amount of mass. Okay, lot of mass is there, and this high gravity also absorbs light. Light cannot escape the black hole, and that's the reason why you cannot see it. Okay, you can see only if something is emitting light, or if light goes and reflects from there. और black hole में दोनों नहीं हो रहा है. Okay, the star has no fusion reaction, so there is no light getting emitted. Number two, if you put a light, the light does not reflect back either. So a black hole is a massive mass that absorbs light, okay, but because it has massive mass and very high gravity, it can attract anything. Anything may, it can consume entire stars. It can consume entire solar systems. ये पूरा खा जाएगा. And remember, at the center of the galaxies, there is generally a very powerful black hole. Whenever you have a galaxy, okay, something here is keeping everything together. Okay, there are millions and millions of solar systems here. Okay, there are a lot of stars here. So what is holding it together? So at the center of galaxies, there's always a massive black hole. Okay, we call this as SNBH, a super massive black hole. The Milky Way के center में एक black hole है, is called as the Sagittarius A. Okay. Every galaxy worth its size and worth its significance has a black hole. It's a very powerful one. It's called as super massive black holes. So what happens is there is a super massive black hole, a very large black hole, and once in a while near the black hole there is some star which is coming nearby. When the star comes nearby, the star gets pulled into it. While getting pulled into it, the star kind of shreds. वो कट जा, टूट जा, disengage होता है. And those small pieces will get pulled into this. They pulled into this. So all of this creates lot of energy. Like it creates a lot of light streaks. Okay, it's like say something is a very powerful attracting body here. Something is nearby. It gets pulled. It breaks up. It kind of explodes, you can say, and ultimately collapses here. So ये जो explosion and collapse into the black hole, okay, is a very powerful event. It's like the star is the breaking up of star. जो टूटता है star, it is called as spaghettification. You know what is spaghetti? क्या होता है? Noodles. Okay, something is there. उसको आपने काट के लंबा noodles बना दिया. Think of that. So this star gets pulled in, it gets totally destroyed, and a streak of light, it ultimately dies off and falls into this. So ये जो event है, it's a very powerful event. And like I said, no, you cannot see a black hole. But if I can see a streak of light like this, it tells me there is a black hole. So this massive event is called as the TDE, tidal disruptive events. And these events help us identify the massive black holes. और इसमें ना बहुत सारा gravity waves भी निकलेगा ultimately. So recently we have discovered quite a few TDEs. ये बहुत rare events होते हैं when you can actually see it and record it. I hope you got the idea what is a TDE now. It was in news, discovered recently. It's not a very common thing. Okay, you can, it happens once in God knows how many years it happens. But if you can observe it, okay, you can know where the black hole is. Yes, Naveen, it has been seen. Okay, बहुत सारे हैं. I'll give you some of the names also. Okay, did you understand the idea or not? What is a black hole? What is a TDE? अच्छा, now एक और point. Don't write right now. I'll give you the notes. Okay, spaghettification is essentially it's like shredding. You know what is shredding? Something getting cut is shredding. Imagine you have a cutter, okay, and something is falling on the cutter. This ultimately breaks into long streaks as a cut jayega. So spaghettification is type of a disintegration of a star when it starts approaching a massive black hole, a supermassive black hole. Okay, now one point. Second point, now look at this. There are black holes, okay, which are even powerful than this. Okay, supermassive black hole, they can be sometimes 20-30 million times powerful than some of the other black holes. In that case, what happens? Rather than a star, entire galaxy can collapse inside this. Can you imagine here? Okay, एक तो है कि a black hole है, black hole में तो दिखाई नहीं दे रहा. Black hole is there, can't see, and you know that it was a star once upon a time. How do I know there's a black hole? once in a while, a star comes near and collapses inside it. And there's a streak of light. Sudden flash of light हो गया और खत्म हो गया. ठीक है? The second is, rather than one star, think of an entire galaxy. The entire galaxy is getting eaten by a supermassive black hole. In this case, there will be no streak of light, but there will be continuous bright light emitting. It's like, it's like one is say a spark of a matchstick, और एक है एक पूरा wood जल रहा है बार बार. So when a galaxy is collapsing inside this, there's a continuous burning going on, and it's a very, very, very bright light. That is what is called as a quasar. ये term सुना होगा आपने. Quasars. They are very rare events and they are very, very far away. Quasars are quasi-stellar radio sources. So जहां पर quasars हैं, the entire galaxy is getting destroyed there. Okay, so these things are all related. Okay, the life of a star, what is a black hole, okay, what is a tidal disruptive event, and what is a quasar. Okay, they all are linked to one another. Black hole, I said, you really cannot see as easily, but they are the ones that ultimately consume, okay, the star solar systems. Sometimes we can identify them when there is a brilliant flash of light and a star is getting disintegrated. ये दिखाई देता है. And quasar is a very, very bright object. It is essentially a supermassive black hole that is consuming an entire galaxy. That is consuming an entire galaxy. Some of these things have been observed by James Webb Space Telescope. Okay, JWST has observed some of these events, and that's how I know, okay, that we can discover the origins about our solar system much better once we decode some of these. ठीक है, समझ में आ गया आपको, all of you here? Now write down some facts, who discovered and all of that. So the first one is, give a heading TDE. TDE. TDE is tidal disruption event. TDE is, now write down, I am dictating it. TDE is tidal disruption event. It is an astronomical phenomena when it is an astronomical phenomena when a star, it is an astronomical phenomena when a star approaches very close to, when a star approaches very close to a supermassive black hole. So close to a supermassive black hole, SMBH, supermassive black hole. The star gets pulled into the black hole. The star gets pulled into the black hole, and it results in a massive explosion. It results in a massive explosion and powerful electromagnetic radiations. As the star gets powerful electromagnetic radiations, as the star gets destroyed and shredded, as the star gets destroyed and shredded. Next point. Recently, some of these TDEs have been observed. Recently, some of these TDEs have been observed, and they are a key to understanding. They are a key to understanding the origin of our universe and solar system. Universe and solar system. And do write this, that TDEs are very rare events. They are very rare events that happen once in 10,000 to 1 lakh years. That happens 1 in 10,000 to 1 lakh years. TDE events also help us identify the presence of black holes or supermassive black holes. Identify the presence of supermassive black holes. Okay. एक नया ऑब्जर्वेटरी है, write down, a new observatory called Vera Rubin, VERA, Vera Rubin, RUBIN, Vera Rubin Observatory in Chile. Vera Rubin Observatory in Chile. That is studying TDEs. That is studying the TDEs. Okay? So just know about this one. Number 2, we write about quasars now. What are quasars? Okay. Quasars are also called as AGN, active galactic nuclei. AGN is active galactic nuclei. And the full form of quasar is quasi-stellar radio sources. Quasi-stellar radio sources. ये quasars भी, okay, these are events that happen very, very far away. They happen beyond our galaxies. Okay? Quasars. So I said quasar is also a very, very powerful, it's also a very, very powerful supermassive black hole. Okay, that it's a very, very powerful supermassive black hole that is active in the sense that it consumes an entire galaxy. It consumes an entire galaxy. Okay, resulting in very powerful and continuous radiation emissions. These are very bright extraterrestrial events, extragalactic events. They're very bright extragalactic events that last millions of years. And are far, far more powerful than the inactive black holes that create TDE. Far, far more powerful than the inactive black holes that create TDEs. Now what I'm saying is, there is a black hole. There is a black hole. It's a very powerful, so super massive black hole hai, and it's dead. There is no light. There is no light. Okay, there is no emissions. There is no emissions. Okay? Now what's happening is that once in a while एक star आ गया and the star gets consumed, okay, and there is a bright emission. There is a massive event called as TDE. One event, then again quiet. So this is like a black hole that is inactive. It is not having any activity. Okay. इसके comparison में, if you look at a quasar, quasar is also a super massive black hole, much powerful than this. In this case, continuously the stars and the planets and the galaxies are continuously getting consumed inside this. इसमें इस केस में क्या है? The radiation emissions are continuous. It's not a one-time event. So, in case of TDE, this is an inactive core. Okay, this is an inactive black hole, which once in a while attracts a star and you can see a bright streak. This, on the other hand, is an active nuclei. इसमें continuously things are getting consumed inside this one. Okay, and this happens in very far away galaxies. Okay, so both of these events are related to black holes, and both of them tell us how our origin happened. Because ultimately क्या होगा पता है? These black holes, they keep on attracting mass. They'll become very dense. Okay, and this mass ultimately somewhere will start shrinking because of massive gravities. Ultimately, यही शायद बनेगा another Big Bang. If you know about Big Bang theory, it tells us there was some kind of singularity. कुछ एक point था, which had tremendous amount of mass. That singularity had all the mass that we know right now of our universe. सब कुछ उसके अंदर में था. Now, physically, we can't even imagine that. Okay, it was a fraction of the size of a needle head. Okay, and then it starts to expand. Okay, it kind of explodes out like a big bang, and we have whatever we have. So the questions are, how do these singularities form? ये बनते कैसे हैं? How do these center of Big Bang form? These could be the stories how they form. Now this itself ultimately will keep on shrinking because of massive gravity, it'll become very tiny. Now physically we can't even conceive this. कि पूरा कायनात, all the creations, all galaxies inside one singularity, and that ultimately expands into the universe of today. Okay, so you understand, I hope, what is TDE event and what is a quasar. So quasar is much larger than any of the regular TDE events. How can mass become singularity? Naveen, बस वहीं छोड़ दो, मेरा भी सर फट जाता है. Okay, when I think about वो कैसे हो रहा होगा, okay, I'm happy I'm teaching geography and not into astrophysics there. And इसका answer I'm sure eludes even the best of the brains. Okay, हम तो सिर्फ mass की बात कर रहे हैं. Okay, these are places where time also is subsumed. और time कैसे absorb हो जाएगा वो हम imagine भी नहीं कर सकते. Okay. However, the black holes discovered in space, it was chance events. Okay, and some of which are related to this one. So some of them have tracked some areas where suddenly no lights comes out. So it was a chance event how they discovered some of the black holes. ठीक है? गैलेक्टिक वेट देबर्गा, एक एक धीरे धीरे करते हैं. ये दो पार्ट हो गया, आई बिलीव. व्हाट इज टीडी अंडरस्टूड एंड व्हाट इज क्वेज़र अंडरस्टैंड. नाउ वन मोर थिंग, अगेन आई विल गिव यू वन सीरीज ऑफ टर्म्स. नाउ there is something called as अभी लिखो नहीं, there's something called as white dwarf. Then there is something called as neutron star. Then there is a pulsar. Then there are black holes. Then there are super massive black holes, okay, which are inactive cores. Okay, इसमें if there is star, there might be TDEs, and then there is a super massive black hole which is active, and this becomes a quasar. Okay. So आपको अगर ये टर्म समझ में आ जाएगा, in some very laymanish terms, you'll have no problem differentiating what's happening where. ठीक है? So it all starts with, don't write down right now, hold on. I said it all starts with a star. It all starts with a star that is dying. Dying का मतलब क्या है? It's a fusion. Reactions of hydrogen to helium has stopped, okay, and it is no longer emitting radiations and light. Okay, it all starts with a star dying. Okay, because when a star is active, when a star is alive, it essentially is emitting light. Okay, think of sun. Sun is emitting light. Yes, correct. All of this I'm telling you because it's related to Aditya mission. Okay, so fine, you got the point here. So a star is active means what? Star is emitting light. All light आता कहाँ से? The light comes from, okay, all the fusion reactions. So for now, just know this: hydrogen atoms will fuse and they become helium. And in the process, some energy is created. ठीक है? Now what happens is, think of a star. A star is not a hydrogen alone. ठीक है? There are many other things also in the star. Other metals भी हैं, other gases भी हैं. They're all there. So when the hydrogen gets consumed, खत्म हो गया, and other matter is still there, the star is not fully dead. Okay, it's still there, but baki matter hai. The baki matter, okay, looks like a very simple dead star called as white dwarf. White dwarf is no longer a burning star anymore. वो ठंडा हो चुका है, and hydrogen has been exhausted, but other matters are there, and the process of its collapse has stopped. Now, sometimes what happens? There is more amount of hydrogen that allows for the process to go on for some more time. So उसमें क्या होगा? The protons, they start converting into neutrons. So a white dwarf, okay, is the simplest of a dead star. जो छोटे stars होते हैं, they become white dwarf. In some stars, the hydrogen amount is enough for the process to go on for some more time, and the protons convert into the neutrons. Then it's called as a neutron star. A neutron star, which for some reasons starts spinning, and once in a while it also starts radiating some energy. Pulsar is a short form of pulsating star. कि ये neutron star ही है, but because of some reasons, the neutron starts spinning, and the spinning action creates some energy. Okay, and it happens not continuously, but in flashes. It'll pulse, it'll be pulsating. Light hoga, again dead. Again light hoga, again dead. So a neutron star converts into a pulsar. When the star is much, much larger than any of this, there is a idea called as Chandrasekhar limit. Okay, it's all about the size of some stars compared to some numbers. If a star is larger than what's called as Chandrasekhar limit, उसमें ज़्यादा amount of hydrogen है, that in that case becomes a black hole. So all of these are essentially dead stars. This is the simplest dead star, which is there, looks like a white ball of mass, but nothing glowing and emitting light in a big way. The white dwarf converts into a neutron star. अगर थोड़ा ज़्यादा हाइड्रोजन होगा, वो convert हो जाएगा. The neutron star can have some reaction, some spinning. The neutron star can convert into a pulsating, the vibrating type of emissions coming out. But if the star is much bigger than some limit, is called as a Chandrasekhar limit. And the man who got the prize, okay, and Nobel winner time. It's bigger than that. फिर ये तीन नहीं बनता है, डायरेक्टली बन जाता है black hole. And the black holes can be very, very massive. We call those as supermassive black hole, and then you know the story. Near the black hole, if a star comes, I can have TDE, and it's such powerful one, consumes entire galaxy, it now becomes a quasar. Okay? So just know this like a stage or different types of black hole. These are the smallest stars, a bit bigger star, a bit bigger star, a very, very large star, and so on. Okay? So write down. Online, did you understand the concept, all of you? See, nobody will ask you any definitions. Okay, but they can ask you questions around this, जो actually बड़े simple होते हैं. If you know the terms, you can handle it. Yes. Ultimately will die, not dead. अभी वो star है, अभी वो bright light है, sun अभी star है ना. But when sun's hydrogen gets exhausted, it can become any of these. More likely, sun इस टाइप का रहेगा, इतना बड़ा नहीं है to become a black hole. Sun will get consumed inside a black hole. Near our Milky Way, there are some black holes. So every possible sun will get consumed and destroyed. So sun का जो size है, it doesn't look like वो black hole बनेगा. It can become one of these. Yeah? Yes, it's like a life cycle. Every star will die. It dies, it'll become one of these depending upon how large the star has been. Okay? So write down. Yeah, all of you good? Did you understand the concepts? I'm sorry, I cannot tell you any book on this. Okay, because I am reading articles. I am keeping update with some of the news that is there. I can't recommend any book to read and clarify all of this. Pulsar, then neutron, and then Abhishek, I do not know beyond this. He's asking me, can a pulsar become this? I do not know. Maybe मैंने पढ़ा नहीं है. I just know कि यही stages बनते हैं. Okay, so reverse होगा कि नहीं? I don't know. I don't think I can answer that. Okay, write down. Write down. Death of a star लिखो. Death of a star. And the possible outcomes. And the possible outcomes. And the bodies related to dying stars. Outcomes and the bodies related to a dying star. No, Satyam. In science and technology, you will study more about the missions. Okay, ये सब नहीं बताया जाएगा कि कौन सा स्पेस क्राफ्ट लॉन्च हुआ, कौन सा सैटेलाइट गया है, what they have seen. But I don't think anybody will teach you because ये थोड़ा geography वाला element है. Know about the stars and the rest. So you'll not go deep beyond this in space technology. You might know some terms. Okay, fine. Let's take up now. The first number one. A star is essentially a large celestial body. A star is essentially a large celestial body which has strong fusion reactions going on, which has strong fusion reactions going on, that results in a star emitting light and radiations. That results in a star emitting light and radiations. When the fusion process stops, when the fusion process stops, because of exhaustion of material like hydrogen, the fusion process stops because of exhaustion of material like hydrogen, a star starts to die. A star starts to die. Okay. Next point. Smaller stars, where hydrogen runs off faster. Smaller stars, when hydrogen runs off faster, and the core is not large enough and hot enough, and the core is not large enough or hot enough to fuse the other elements, it collapses to become a white dwarf. It collapses to become white dwarf. Is a small star. Okay. Hydrogen jaldi khatam ho gaya and the pura collapse hua nahi hai. It becomes a white dwarf. Next. Relatively bigger stars that have enough hydrogen and helium, to continue fusion further, and have stronger gravity, convert into neutron stars, after supernova explosions. It's like, a star is dying, it's dead, white dwarf. Further collapsing, and some reaction, it explodes. Then it becomes a neutron star. Okay. Third one. Okay. A neutron star that starts spinning and start emitting radiations. With some periodicity. A neutron star, okay, that starts spinning and emitting radiations at some periodicity is called as a pulsar. Pulsar is called as a pulsar. So pulsar ka full form hai pulsating star. Full form of pulsar is pulsating star. Next, when a dead star has a much massive core, and becomes very, very dense, has a much massive core and becomes very, very dense, it becomes a black hole. Black hole that doesn't allow for light to escape. that doesn't allow for light to escape, and becomes an inactive galactic core. It becomes an inactive galactic core. Next, such inactive massive black holes can force some stars to collapse into it. Leading to spectacular and very rare events. Called the TDEs. Tidal disruptive events. Okay, so ये black hole ही है, but once in a while it is catching a star. And remember that in TDEs, the black hole is actually inactive. कोई light निकल नहीं रहा है. It's inactive and it happens to attract some star. The last one, very large and supermassive black holes, very large and supermassive black holes, when start consuming entire galaxies, they're referred to as active nuclei. And can emit enormous amount of energy and radiations. And are better called as quasars. Okay. Put a star mark. Study of black holes, TDEs, and quasars hold the answers to the origin of our universe. ठीक है? So I explained some of the terms जो आप सुनते रहोगे more or less in news and otherwise. I don't think they'll ask you question beyond these tricky concepts. Okay, what are they and some facts there. Okay. Now, again a very recent discovery. Okay, जो confirm किया actually, something called as gravity waves. Maybe you have done this in science and technology. Okay, but I would have to mention this again so that our discussions of space is complete. Gravity waves. Okay. Now see what happens is, think of this is some surface. In this surface, there is some matter, and think of these lines as lines of time. So I am here. After 1 hour, I'll come here. After 1 hour, I'll come here. Time T3, I'm here. Time T4, I'm here. Okay, very linear. Okay, you can say fabric of time and space. Think of a map. Okay, ये surface है कोई, some surface. This surface has some matter, and there are lines of time. If I'm moving at a speed x, after time t1 I'll come here, after t1 2 I'll come here, and so on. our space also has these kinds of, time and space concept. What happens is, if there are certain massive events, think of a TDE event here, or think of a major quasar event going on here. This energy that is thrown out, it kind of disrupts the entire space. It's like, I'm holding a sheet. Imagine I'm holding a sheet here. Okay. The sheet represents locations and the sheet represents time. If I travel, ये time में travel करेंगे हम. But यहाँ पर there's some kind of a massive event here. A massive gravity collapse, a TD event, a quasar event. One of you asked me, if there are two black holes and the two black holes will say coalesce, this energy is so powerful, ये पूरा को ना ऐसे disrupt कर देगा. I mean, difficult for you to understand this. So just an example के लिए, say this is time t1 and this is time t2. Okay. If I move linearly, I know exactly time 1 कि ये speed में जाकर I will reach time t2. But if this fabric, for some reason has got distorted, so ये time t1 है, ये time t2 है, ये ऐसे मुड़ गया. Okay, can you see now? Time t1 and t2 have come closer to one another now. And अगर ये बार-बार ऐसे होगा, ये probability can also merge. That's what becomes time travel, hypothetical mathematically. Okay, so we call this as the fabric of time and space. When there are massive events, this fabric of time space can get distorted. ऐसे distort हो जाएगा, ये shake हो जाएगा. Okay, and this shaking gives off some kind of waves, and we call those as gravity waves. Gravity waves happen when, I said no, black hole type of events start occurring. Gravity waves was a mathematical concept. सबसे पहले एक experiment था LIGO, LIGO, I'll talk about it, that detected कि gravity wave है, but वो बहुत weak था. Recently, we have actually found and we have evidence of that universe has many such gravity waves happening. So what we will witness in the universe is not simply light coming to us, is not simply radiations coming to us. We also witness gravity waves coming to us. And these gravity waves can distort a lot of things. If they're massive ones, who knows, even the orbits of the planets can get distorted. So, gravity waves are, you can say, one type of energy coming out, which is not like the regular energy of heat and light or radiations nahi hai. Okay, and this has been a part of a experiment. Okay, I'll talk about the details in that. Yes, Ganesh, you're right. It distorts the time-space graph. Okay, so give a heading, gravity waves. Now write down something. Write down. The universe and the heavenly bodies, the universe and the heavenly bodies can be three-dimensionally represented as, as fabric of space and time. Fabric of space and time. Abhinav, I can understand your confusion here. इसीलिए मैंने आपको example दिखाया, in terms of a visible thing. We are not able to imagine this. Mathematically, they have said, time can also get distorted. इसका यही example मैं बताया. I am here today. My age is 30 years. After 10 years, I become 40 years. After another 10 years, I become 50 years. This is when the time-space fabric is flat. Imagine I am 10 years, 40 years and 50 years. For some reason, if this fabric is to bend like this, can you imagine here? I am 10 years I'm very close to 50 years directly. I can bypass the 40 years. And imagine, agar ye dono mil gaya. Agar mil gaya, then my 10 years of age and 50 years will collapse. That's what is time travel. Okay? So for us to imagine becomes difficult. So we talk in terms of a time space. Okay? And universe में ये disruptions होते रहते हैं. And that's where, you have lot of confusion about कि ऐसा कोई machine बन सकता है क्या where we can travel across time. There's the idea called wormhole. Okay, I can bend like this and there can be conduit. I can enter from 10 years, 50 years directly. Okay, so for now, keep it as a hypothetical imagination. How will it manifest? Okay, too early for us to comment. Mathematically correct, yes. Yes, Naveen. Some of these have been part of those sci-fi movies. Yes, Interstellar is example of that, correct. Many such movies of this kind. Okay, continue that down, right next. So I said you can represent all of that into a time-space fabric. Right next. This time-space fabric can be distorted. This time-space fabric can be distorted and disturbed. Can be distorted and disturbed and can form ripples and waves. And can form ripples and waves. So this is the time-space fabric. Okay. These are the lines and this sheet can now get distorted like this. As it distort ho gaya. You have, kind of, disturbed it. So the lines have now got bend here. It's like some kind of event which is kind of making wavy motions on this. Write down. These disruptions can happen because of events like black holes collapsing or supernova explosions. Black holes collapsing or supernova explosions, or events like TDE and quasar eruptions. Okay. Next point. Our outer space is full of such waves. Our outer space is full of such waves called as gravity waves. They're called as gravity waves. They are like background hum sound. They're like background humming. Background hum sound in the universe. जैसे कि ना कोई इवेंट हो गया, उसका रिपल जो है वो स्पेस में घूम रहा है. ओके, सो वी नो साउंड वेव्स, राइट? साउंड एक वेव्स होता है. सो इट्स लाइक आई क्लैप. आफ्टर क्लैपिंग some sound or echo remains in the air. Think of the massive events like major clapping. उस clap की वजह से some waves are there in the universe. Okay, they are like background sound in the universe. Now, for the first time, we have detected this and we also have evidence of this. These gravity waves as background space murmur, hold evidence of past events of billions of years. They hold evidence of past events over billions of years. Okay. Next, gravity waves were first detected by LIGO, L-I-G-O, by LIGO. Okay. LIGO full form is laser interferometer. Laser interferometer gravitational observatory. Laser interferometer gravitational observatory. Okay. This is a collaboration between NASA and ESA, European Science Agency. Collaboration between NASA and ESA. Next, recently, okay, the presence of such gravity waves, has been proved to be correct. By nanograph study. Nanograph का फुल फॉर्म है नॉर्थ अमेरिकन nanograph study, North American nanohertz, nanohertz observatory for gravitation waves. North American nanohertz observatory for gravitation waves. And this is a collaboration between US and Canada. Collaboration between US and Canada. Okay. So you asked me, what happens if two black holes merge? So now we have this gravity studies that tells us black holes merge and what ultimately can distort the entire space. Okay. So again, linked to black holes ही हैं. Okay. The study of gravitational waves are also related to the black hole studies. Okay. Again, come back to origin of the universe and the solar system. Okay. I'm done with this. The next topic, again related है, the concept of Lagrange point. Again, it's a bit of science and technology. It was the news in relationship to Aditya mission. Lagrange point. L-A-R-A-N-G-E. Lagrange point. Have some of you read this already? You heard about it? Okay. Fine. If you have heard it, let me repeat it. Others understand this. Now see, what happens is, Lagrange point, L-A-R-A-N-G-E, Lagrange point. So what happens is, when there are different celestial bodies, okay, the sun, this is Earth. Sun is pulling the Earth. Earth is also pulling the sun. The sun, while it is rotating and it is revolving, there is some centrifugal push of the sun. Earth, while rotating and it is revolving, it also has some outward push. In the space, there are many such interactions going on. Okay. For any body which is between sun and earth, it's possible, say a body enters this. either sun will pull it like this, or for possible, the earth will pull like this. So any body which enters the orbit between these two will get distorted. Say I have an aircraft. Okay, the aircraft must come here. While coming here, okay, it's possible that sun has pulled it. So I must use engines and again bring it back here. Okay, again sun pulls it. Again I'll use the engine to again come here. So I have to keep on using energy, fuel to escape the sun's attraction, and then slowly, gradually I'll come here. Or the body is moving like this, okay, earth will pull it. If earth pulls it, I must again use an engine to again come out and come here. Again earth pulls it. Again I'll come here. So slowly, gradually, again I'll come here. But there is a path, कोई एक बीच में point है, where the sun's pull and the earth's pull are perfectly negated. Okay, इस path में क्या होगा? The body will not need more energy. It will smoothly go and come here. So this is like an orbit of balance, where the various gravitational pull ultimately balances. तो इस path में अगर जाएगा ना, the aircraft or the spacecraft will not require additional fuel. It can conserve its energy and it can manage to be very economical in its flight path. So what happens is, in interspace travel, there's some bodies going from here to Mars, or going to Saturn, or going to Neptune. They try to take a path which is in between these gravity fields. It's like a highway. Okay, so imagine this is one planet, another planet, a third planet, a fourth planet. My spacecraft कुछ एक बीच का path निकालेगा, okay, some path in between, which is having the least disruption in the orbital path. We call these as intergalactic transport network highways. They want to travel to outside space. अगर मुझे ये path मिल जाता है, okay, I can move very, very smoothly. Okay, this concept called as intergalactic transport network highways. So spacecrafts which travel across planets, and tomorrow when spacecrafts will travel across galaxies, we need this kind of pathways so that will not be consuming more energy than required. Okay, that's one concept. Second concept is, this is the sun, and or this any two bodies, sun and earth ho ya, or earth and moon jo bhi ho. Okay. Now in this space, and this is the orbit of the earth. Okay. There are some locations where this type of balance happens. There is one location between sun and earth. यहाँ एक location है. There's one location beyond earth. यहाँ पर location है. Okay. There is one location on this side where the centrifugal force is balancing the gravity of the earth, of the sun. The centrifugal force of earth is balancing the gravity of the earth. Okay. This is L1 point. This is L2 point. ये एक L3 point है. These are those locations where the gravitational, okay, disruption of orbit is the least. वैसे दो और point है. See, if this is sun, this is earth. If I draw an equilateral triangle here, यहां पर भी एक point है. It's called as L4 point. And between this also, यहां पर भी एक point है. It's called as the L5 point. These are the 5 points where there is least disruptions, okay, in terms of orbital path, because the gravity gets balanced. ये points को बोलते हैं Lagrange point. Have you got the point here? Did you all understand the concept, online and offline? ये कुछ locations हैं. The locations where the gravitational pull, it's balanced by some other factor, because of which, if a body is moving, the orbital distortion of that body will be the least. Any other place, okay, either sun will pull it or earth will pull it. And you need lot of energy and machines and fuel to bring it back to stability. Find all of you here? Okay, we call these as Lagrange point. Aditya is here today. It is at L1 Lagrange point. Okay, it has traveled approximately what, 1.5 or 1.3 million kilometers. January 6 को आदित्य यहां पर स्टेशन हो गया. So it's a very nice point where it can stay there for a long time without using too much of energy. जेम्स वेब टेलीस्कोप जो है ना, वो यहां पर है. It is at the Lagrange point 2. Okay. Anyways, I'll give the facts to you. Write down a few lines on. Okay. No, it doesn't become stationary, Satyam. If I'm not spacecraft, satellites, if satellites are in this position, what happens is, you will not need too much of correction. Otherwise, क्या होगा? मुझे satellite को यहीं रखना है. Because of sun's gravity, the satellite get pulled here. So I must again bring it back here. It again gets pulled. It again must be brought back here. अगर तो इधर रख लोगे, the earth will pull it. Okay, and again you must fire engine to again bring it back here. So this is costly. If I can find a point where the balance is maintained, तो वहां से क्या होगा? I will not need to do too much of corrections. Okay, it doesn't become stationary. It's just that at that location, I will not require too much of maneuvering. ठीक है? Okay, write down now. Write down. Lagrange points are points of equilibrium. Yes, something like that, Satyam. Lagrange points are points of equilibrium of small mass objects. Points of equilibrium of small mass objects under the gravitational influence of two massive orbiting bodies. Influence of two massive orbiting bodies. Okay? So Lagrange point क्या है? It's a point of balance. It's a point of equilibrium for small bodies. ये अपने आप में बहुत बड़ा नहीं है. Small satellite, a small spacecraft. Okay, between two massive orbiting bodies. Right, next. At the Lagrange point, the small bodies maintain a condition of balance. And hence require least orbital corrections. And therefore least fuel requirements. Least orbital corrections and hence least fuel requirements to maintain their orbits. At any other locations, there will be orbital distortions. At any other locations, there will be orbital distortions that requires continuous intervention. For orbital correction. ओके, आई रिपीट. ओके, माय गॉड, आपका जो ऑनलाइन नाम भी है, इट सेज हेडेक. ओके, सो इसमें तो समझना वैसे ही मुश्किल ही है. ओके, सो फाइन, हेडेक. ओके, so here is the repeat. Okay, you are very sure about what you do to others. Okay, anyways, so I repeat here. When there are two massive bodies, this is body 1, maybe in this case it is sun. There's another body which is body 2, that is earth. Okay, between all of this, there's lot of gravity going on. Okay, and I want my aircraft to be at some position. Okay, अब ये position maintain करने के लिए I have to keep countering either sun's pull or counter earth's pull. I have to keep on balancing that. But if there is a position where both the pulls are perfectly in balance, फिर मुझे ज्यादा कोर्स करेक्शन करना नहीं पड़ेगा. Okay, it's like if I'm on this side, this pulls me more. If I'm on this side, this pulls me more. In between somewhere, the pull is equal. So I will not require too much of force to balance myself. That's all. It is a point of equilibrium. It's a point of balance where the gravitational pull of massive bodies gets neutralized. Therefore, to maintain the satellite at this position, I will require least fuel. I'll require least amount of energy to keep on doing the corrections. इसको बोलते हैं Lagrange point. Okay, and between two bodies, mathematically found that there are 5 Lagrange points. One Lagrange point between these two is called as L1 Lagrange point. One is on this side, where the gravity of Earth is managed by the centrifugal force, is called as L2 Lagrange point. There's one Lagrange point on this side, is called as L3 Lagrange point. Okay, and along this orbit, ये अगर orbit है इसका, okay, sun, Earth का, along this orbit, if I was to draw an equilateral triangle, okay, ये दो center and one point on the orbit here. If I draw an equilateral triangle here, like this, where this angle is 60, this angle is 60 degrees. Okay, so these two also are two more Lagrange points. आप derive ना करो, आप बस जान लो कि ये points हैं, that's all. There are two more Lagrange points here. This is called as L4 Lagrange. This is called as L5 Lagrange. That's all. Naveen, let's not get too much curious beyond this. इतना काफी है. What are Lagrange points? और हम क्यों पढ़ा रहे हैं? Because आदित्य मिशन जो है वो Lagrange point 1 में स्टेशन है. This year itself, January 2024, 6th of January, it entered this Lagrange point. Okay, and this position is approximately, I think, if I'm not wrong, about 1.5 million kilometers from Earth. Okay, it is now stationed here. And there are other satellite telescopes जो other Lagrange point में है. So L2 Lagrange point में we have a James Webb Space Telescope. Okay, that's about it. Okay, so our fact was the Aditya mission, Aditya 1 mission, the solar observatory mission for India is now positioned at L1 Lagrange point. ऐसे imagine between many bodies. So ये एक हो गया, फिर एक और बॉडी यहां पर है, इसका भी फिर L1 होगा, L2 होगा, L3, L4 होगा, ऐसे कुछ और बॉडी है. If I was to join all of this, अगर मैं ज्वाइन कर लेता हूं, Can you imagine? This almost becomes like a highway along which satellites can travel, probes can travel. So this becomes the intergalactic transport network highways. Like if I can combine such Lagrange points and know the locations, आराम से बन जाएगा, एक pathway बन जाएगा. Which point is better, Abhishek? It all depends on क्या experiment कर रहे हो. Generally L1, L2 ही पकड़ते हैं because ये बहुत दूर है. Understand this. हम यहीं पहुंचे हैं, आप सन को क्रॉस करके यहां पर आओगे. I don't know. How wise is that? Okay, so as of now, most of our observatory satellites are either at L1 or at L2. Most prefer L2. Anybody can tell me why? Yes, to shield it from the solar radiations. But Aditya तो सन को ही पढ़ रहा है ना, इसीलिए आदित्य को L1 में रखा है हमने. Have you got the point here? All other space probes जो हैं, all other satellites जो हैं, okay, they are on the L2. Where L2, they can protect themselves from the massive solar radiations. Okay, space probe का काम है पूरा यूनिवर्स को पढ़ना, तो ये रखो आप. But Aditya must study sun, right? That's why it is at L1. Which is preferable? L2 is more preferable for most of the probes, but for solar missions, L1 is preferable. Yes, इनका भी रोल है. L4 and L5 का भी रोल है. What happens is, in these positions, because there is minimum disruptions, lot of rocks, lot of asteroids, they can get trapped here. Okay. कहीं और होगा. Say this is an asteroid, sun can pull it. This is an asteroid, maybe some other planet can pull it. But at this position, Lagrange 4 and 5 में, lot of rocks get accumulated here. Okay, and they kind of become a satellite for this planet. So Jupiter के केस में बहुत सारे ऐसे points हैं. Okay, and these satellites, they are called as Trojans or satellites. Forget it, don't write about it. Just know this. So between, we know about Earth and Sun. वैसे ही Sun and Jupiter में भी ऐसे Lagrange points हैं. So for Jupiter, okay, because of its massive size, so imagine if I was to draw this. Say this is Jupiter. Okay, this is the orbit of Jupiter. For Sun and Jupiter, I have got Lagrange 1 here, Lagrange 2 here. But this is Lagrange 4, Lagrange 5. For Sun and Jupiter, this Lagrange 4 and Lagrange 5 has lot of trapped asteroids. Okay, and we call those as the Trojan satellites of Jupiter. इसका भी नाम है. Okay, Trojan satellite, Kepler, whatever. Forget about that right for now. ठीक है? So I just wanted you to know L1 and L2. Aditya is at L1 and James Webb Telescope is at L2. All good here? Online students, you are too quiet. I hope आपने notes लिख लिया है. All fine? All keeping pace with me, online students? All keeping pace? Yes. The line, Lagrange lines? Okay. All fine? Okay. So I'm done with this. You can know, जैसे James Webb Telescope है. James Webb Telescope is a NASA project. James Webb Space Telescope is a project of NASA. So वैसे European Space Agency का ऐसा ही telescope है. Anybody knows the name? It's called as Gaia. Gaia. There's the Gaia telescope. Okay. This also is positioned at L2. Gaia telescope of European Space Agency. Okay. और यूरोप ने एक और नया लॉन्च किया है, एक और टेलीस्कोप कॉल्ड एज यूक्लिड, EUCLID, यूक्लिड. both of these are also at Lagrange 2 positions. They're also at Lagrange 2 positions. Okay. So I'm done with black holes, gravity waves, TD events, Lagrange point also linked to gravity of bodies. Galactic means galaxy से related. Galactic travel, galactic events, anything related to galaxy is called as galactic. Galactic center is center of gravity. Galactic event, an event in some galaxy. Galactic collapse, a galaxy is collapsing. Okay? Okay, fine. Next, let's take down one more concept. Solar flares and coronal mass ejections, also called as CME. ये भी न्यूज में है एंड इससे क्वेश्चंस भी पूछे गए हैं. सोलर फ्लेयर्स एंड कोरोनल मास इजेक्शंस. कोरोनल मास इजेक्शंस. Okay. Now, before I move on to this one, you must know something about the sun. Sun का surface है. There is a surface of sun. Okay. And above this is also the atmosphere of the sun. It has something beyond it. Now, this sun का जो lower layer है, okay, the lower layer is not same as the upper layer. The lower layers are called as, okay, chromosphere. And the outer layers are called as the corona. It's like the crown. This is the sun. This is the sun's surface, and there is corona. Okay. The lower layers are called as chromosphere, and the outer atmosphere is called as the corona. Okay. Now it's a very interesting thing. Corona is farther away. Okay. But corona is the hottest. Okay. And this is the mystery. They have tried something, but the source of all heat kya hai? वो तो sun ही है ना. So actually, if you go away from sun, it should have become cooler. Okay, but ऐसा नहीं है. If you go away from sun, okay, corona is actually the hottest part. It is couple of million degrees hotter than the chromosphere and the surface. This is the hottest part, corona. Corona has lot of plasma. Plasma are like ions. It has lot of plasma. It also has lot of magnetic radiations. It is not a regular type of an atmosphere. Okay. The sun's surface is hot. The lower layers of atmosphere is the chromosphere. And uske baad hai corona. Corona is very hot. Corona has plasma. The corona has lot of magnetic radiations coming out from corona. Okay, that's one fact. Now another fact is corona, although it is the hottest, it is not visible. It is not visible because chromosphere is the brightest part. तो ये छुप जाए, ये दिखाई नहीं देता. If you look at the sun in a regular say observations, what you see is the sun's surface and the chromosphere. Even telescopes cannot see the corona because the more bright part is the chromosphere. Okay. This is not as bright. It's very hot, but it is not bright. Like think of Earth का एक thermosphere है, right? Which has lot of heat, say lot of temperature, but not very hot. ठीक है? So just know this. So write down here, the sun and its atmosphere, the sun and its atmosphere have different layers. The sun and its atmosphere have different layers. The lower layer of the sun, the lower layer of the sun is called as chromosphere. It's called as the chromosphere. And the outer layers of the sun's atmosphere, the outer layers of the sun's atmosphere is called as the corona. It's called as the corona. The corona is extremely hot. It is the hottest part. Next point. Right, always point wise. Okay, paragraph में आपको याद नहीं रहेगा. Point wise. Next point is the corona is the hottest part of the sun. The corona is the hottest part of the sun. It has plasma and magnetic radiations. It has plasma and magnetic radiations. Despite its heat, the corona is not visible. The corona is not visible because the chromosphere is very bright. Because the chromosphere is very bright. But अगर solar eclipse हो जाता है, okay, I hope you know what solar eclipse is. क्या होता है बताओ? What gets hidden? The sun. Why it gets hidden? Because the moon comes between the earth and the sun. तो ये sun है, this is the earth, and between these two, moon is there. Because of which, okay, the sun can get, okay, eclipsed. It gets blocked. जब sun block हो जाता है, then the outer layer seems to be visible like a ring. So corona is only seen in times of full solar eclipse. In times of full, corona is only visible in the times of full solar eclipse. Okay, so within bracket mention, the moon is between the earth and the sun. So moon का shadow पड़ता है, okay, and we cannot see it. Or moon not shadow से moon block कर देता है, so we cannot see it. Okay, we cannot see the sun, but जो corona है, so it's like this is the moon blocking, and then the corona around this now starts getting visible. ठीक है? Do you understand what a corona is? Okay, now next point here is what happens is because of certain, again, fusion reactions बोल लो, certain type of radiation reactions बोल लो, whatever, this corona sometimes throws out more amount of plasma. It throws out more amount of electromagnetic radiations. Those look like flames coming out of, okay, the corona. And this is what's called as the solar flare. The solar flare are one type of sudden eruptions. Write down. Write down. Solar flares are intense sudden eruptions. They are sudden intense eruptions of electromagnetic radiations. From the corona of the sun. From the corona of the sun. Okay. The eruptions have the eruptions have more of plasma and emit out electromagnetic waves. They emit out electromagnetic waves. Generally, solar flares have a periodicity of 11 years. Solar flares have a periodicity of 11 years. Next, in solar flares, charged particles travel at very high speed. They travel at very high speed, okay, and can move towards the earth. So, बताओ, when charged particles come from the sun and very powerful ones, how they impact earth? क्या कर सकते हैं अर्थ में? Yeah? Okay. So remember, ये solar flares, they're pretty frequent with some period and powerful होते हैं, but they do not have any significant impact on earth and its climate and life. Remember this. They are very powerful radiations. Okay, they are charged particles. Okay, but they do not have any significant impact on Earth, its climate and life. Why? Because the solar flares के जो charged particles हैं, they are absorbed. They are absorbed and they are neutralized by the Earth's ionosphere. They are absorbed and they are neutralized by the Earth's ionosphere. Yes, you're right, Naveen. Sometimes, okay, these charged particles, they can interact with Earth ka ionosphere and they can create, okay, display of light, okay, called as the auroras. Otherwise, climate pe ya temperature pe, they do not have much impact. Okay, they don't cause, they have hardly any impact in our lives, okay, because of this. They might cause display of lights called as auroras, but they are benign, they don't impact us. However, the solar flares can disrupt communication systems on Earth. They can disrupt communication, okay, systems on Earth. But otherwise, our atmosphere shields the Earth from, such cosmic radiations. It shields our Earth from such cosmic radiations. ठीक है? इस पे क्वेश्चन था year before last, and many of them wrote solar flare cause global warming. They don't. Solar flares will not cause forest fires either. At best, they can disrupt the systems of communication because ions hain, the radio wave communications can get impacted. That's all. And remember one thing, the 2025, we are anticipating a massive, okay, solar flare event. 25 predicted hai, we'll have some event there, but negative impact, okay, not as much probably. Okay, next. What is, what is, even magnetosphere, correct Debarga. Even the magnetosphere okay, is able to absorb them and deflect them. You're right. Ionosphere and the magnetosphere. Next is, what are coronal mass ejections? Coronal mass ejections. Just to differentiate here, think of again the same idea. Okay, that I have a matchstick. The matchstick is lighted. You have a flash of light. और वो बुझ जाता है. Second is, think of, I have a flame, okay, continuously burning on maybe a piece of wood. In both cases, I have got light and heat. In case of matchbox, क्या है, sudden spark होता है, it's over. Sudden spark, I feel hot, okay, I remove my hand, it's over. But think of, okay, a wood burning continuously for a longer time. So coronal mass ejections are more powerful, more continuous, unlike solar flares. Solar flare is like a burst of energy, it stops. But this happens like a cloud coming out and much more powerful than a solar flare. And they may not be related. Not all solar flare are from coronal. Coronal as in corona of the earth, and mass ejection. Massive amounts of plasma can come out. Massive amount radiations is coming out, but not less as the solar flare. It's something like, again, the TDE event, जो एक spark event जैसा लगता है, and the quasar event is a continuous burning of entire galaxy. तो वैसे कुछ imagine करो difference. Okay, write down now. Coronal mass ejections. Coronal mass ejections. On the other hand, are massive events of large expulsion of plasma and magnetic field. Plasma and magnetic field. It can involve billions and tons of coronal material. It can involve billions and tons of coronal material, and it can travel from the sun at more than 1,000 kilometers a second. More than 1,000 kilometers a second. The CMEs can also impact the Earth's magnetic field. Just like shock waves have an impact. Just like shock waves have an impact. Next, 2023 witnessed one major CME. 23 witnessed one major CME where it seemed like a part of sun was blown off. A very large CME where it seemed like a part of sun was blown off. There's a gaping hole जैसे हमें लगा कि sun में missing mass है, was blown off. Next, like solar flare, CMEs can cause magnetic storms. And again, they do not impact our Earth significantly. Except for disruptions in communication, disruptions in communication, blackout of electrical grids, and space missions. Okay. तो ये क्लाइमेट को इंपैक्ट नहीं करते हैं, दे कैन इंपैक्ट अदर थिंग्स. अ पॉइंट इज देयर विल नो ग्लोबल वार्मिंग बिकॉज ऑफ दिस. दैट्स अ रॉन्ग आइडिया. नो ग्लोबल वार्मिंग, no forest fires, no extra melting of ice or the oceans. But yes, the other impacts are our systems of electrical grids can get impacted. There can be blackout, there can be communication blackouts, a space communication problem ho jayega. Like otherwise, no other impact on Earth and its life. ठीक है? So I'm done with solar flares and CMEs. Now quickly take a list of important space missions probing the outer space. Important space missions probing the outer space. And please tell yourself, read this with science and technology topics. Okay, read this with science and technology topics. I will only mention them, but the details of the missions are done as a part of science and technology. So space itself is about 2 or 3 classes में होती हैं. Okay, so look up that. I'm giving a list from my side. Write down. One is the New Horizon mission. New Horizon mission. This is the first spacecraft mission to explore Pluto. The first spacecraft mission to explore Pluto and study the Kuiper belt. I hope you know एक और mission था called as a Voyager mission. Voyager has gone towards the edge of Earth's solar system. Within bracket mention an older mission called as the Voyager mission has crossed Pluto towards the edge of our solar system. Crossed Pluto and gone toward the edge of the solar system. एक और मिशन का नाम है ओजिरिस रेक्स. OSIRIS. Osiris -Rex. Rex. This is to study how planets are formed. And it will get samples from an asteroid called as Bennu. Bennu. Samples from an asteroid called as Bennu. Bennu. Next is Parker Solar Probe. This will touch the sun's corona and study coronal heating. It touches the sun's corona and study coronal heating, corona of the sun. Okay, Parker Solar Probe. Next is Juno mission. इस पे क्वेश्चन पूछा हुआ है. Juno, Juno, Juno mission to study Jupiter and its formation. It will enter Jupiter's atmosphere. Then we talked about Dawn mission already. Okay, mission Dawn. Okay, it was to the asteroids. Okay, mission Dawn. Next is James Webb Space Telescope. JWST. Okay, it is the largest infrared optimized telescope. The largest infrared optimized telescope. Its objective is to study the origin of universe. To study the origin of the universe. It has studied the first light. It has studied the first light from the Big Bang explosion. First light from the Big Bang explosion. और एक बताया था मैंने इनसाइट मिशन, INSIGHT, इनसाइट मिशन to study Mars, to study Mars, and to study the tectonic activities of Mars. How does the interiors of Mars operate and look like? And the next one is a core mission called as Mars 2020. इसका ऑब्जेक्टिव है to get back rock samples from Mars. Mars 2020 to get back rock samples from Mars. And the rock samples will be collected by Perseverance rover. There's one rover on the Mars. Samples collected by Perseverance rover. Perseverance rover. Fine, all of you? That's more or less the space. Okay, what are the events, terms, probes, and so on. Online, all keeping pace with me? All keeping pace with me? All fine? Yes? Okay, so we'll go on for some more time. So you can take maybe a 5 minutes of break. Okay, catch up on water, bio breaks. Meanwhile, revise whatever I have taught you. Okay, and we'll get back again. No, Devarga. No. Okay, moon is beyond that. Okay, no. Lagrange point is for man-made satellites. Okay, which we tend to use. So moon can be at different locations depending on apogee hai, perigee hai, aphelion hai, it varies. Timing of this class, I'll start another 5 minutes ke baad mein. We began the class at 8:30 in the morning and the class will go on till 11:15, 11:30 tak. Again, building blocks, Nisha. They are building blocks. Naveen, I do not know. Okay. I'm assuming kuch naam hoga, but I do not know. But if you asked it, maybe you have read it somewhere, you can refer it back again. So take a quick break and come back in 5 minutes. And meanwhile, you can revise. If you want to clarify something, ask me. Nisha, what's the question? Welcome back. Corona is few million centigrade. How does Parker solar probe withstand atmospheric? छोटा सा आदमी हूँ, ओके, दिल्ली के कोने ओआरएन में, करोल बाग में. माई स्ट्रगल इज कि चाय गरम मिल जाए. ओके, दैट्स अबाउट इट. So how they manage? Let us trust. Scientists will find a way, nothing of which I have any information. Maybe some material hoga वैसा to sustain, or maybe they'll send up to find out what more could be done. But I have no information about that. I do not know. Okay. So all the new students and also old students, I hope all of you keeping pace. That's always my concern. And I will move at a pace. Hopefully all of you can catch up with me. But if you miss out, do ask me. Online also, offline also. But ultimately your writing speed has to be really good. And that's one reason why I say your study must include lot of writing on the paper. Not simply reading on the books. Okay, or listening to podcasts and YouTube alone. आपको लिखना पड़ेगा. Your hand must get that dexterity, that fluency, the comfort to write very fast. ठीक है? Any case, if you miss something, do let us know. Are you all guys back? Can you all confirm if all of you are back? Hi Ganesh, Nishant, Abhinav. Yes, Jatin, Naveen, Satyam. Okay, fine. Now, a very quick list of certain theories of Earth and solar system origin. Okay. So, theories of Earth and a solar system ka origin. I'm just giving a list to you. Okay, this is not the complete list, but the more important names are here. To just know this mechanic. No questions asked on this yet. Most questions on these are very contemporary questions. Okay, but know the names. One of the old theories is called as a planetesimal theory. This was given by Chamberlain and Moulton. Planetesimal theory of Chamberlain and Moulton. Number 2, it is the nebular theory. This was given by Kant. This was an old theory which is now discarded. एक नया theory है given by Laplace. This is still accepted to some extent. Nebular theory of Laplace. The third theory is called as the tidal hypothesis. The tidal hypothesis. This was given by two people, Jean and Geoffrey. Jean, a French scholar, and Harold Geoffrey, an American scholar. Tidal hypothesis of Jean and Geoffrey. Then we have the fourth theory. It's called as interstellar dust hypothesis, given by Schmidt, a German scholar. Interstellar dust hypothesis, given by Schmidt. Just know the names, no questions asked. Okay, just know the names. एक और थ्योरी है बाइनरी स्टार हाइपोथेसिस. बाइनरी स्टार hypothesis given by Russell. Binary star hypothesis given by Russell. एक और है सुपरनोवा एक्सप्लोजन थ्योरी. सुपरनोवा explosion theory. This was given by Hoyle, Hoyle, supernova explosion theory of Hoyle. The seventh one, the more famous, Big Bang theory. Big Bang theory, there are many scholars here. There is Lamaitre, there is Gamenov, a Russian scholar, Gamenov, there is Hubble. Hubble proved that our universe is expanding. Okay, he proved our universe is expanding. There is a concept called as the red shift and the Doppler effect. This proves that Earth is expanding. When the radiations are coming from outer space, if the radiations seem to be shifting towards red, the frequency, अगर change हो रहा है, कम रहा है, we call that as red shift. Just know this fact. Red shift and a phenomena called as Doppler effect is a proof that our universe is expanding. And because universe is expanding, that's why some said कि it's possible, it's consequence of the Big Bang. Otherwise, कोई चीज ऐसे फैलेगा क्यों? Indirectly, we say that Hubble probably gave evidence of the Big Bang. Big Bang is the most accepted one, although it also has lot of inconsistencies. The Big Bang theory. Mani, what did you miss? Batao. Supernova explosion of Hoyle, the Big Bang theory of Lamaitre, Gamenov, MAITRE, TRE. Okay, the first 5. Here they are. लिख लो, if you miss something. Planetesimal theory of Chamberlain and Moulton, nebular hypothesis of Kant and Laplace, tidal hypothesis of Jean and Jeffrey, interstellar dust hypothesis of Schmidt, binary star hypothesis of Russell. Binary star hypothesis of Russell. And you might know one thing, that just some points here. The tidal hypothesis, this best explains the size of the planets and their arrangement from the sun. This theory best explains the size of the planets and their arrangement from the sun. लिखा आपने? Laplace theory best tells us how the nebular cloud may have formed the planets and the stars. How the nebular cloud may have formed the planets and the stars. This theory was among the first to try to explain the formation of interiors of Earth and continents and oceans. हालांकि गलत था, but it was among the first to try to explain the interiors of Earth and the formations of the oceans and the continent. Okay, just some points in some of them. You may skip the details of the rest. The interstellar dust hypothesis, this is very similar to the nebular theory. This is very similar to the nebular theory. Okay. So guys, I'm done with this topic of space and solar system. Now we'll move on towards Earth. Okay. Space, I don't think you'll require more than this. Okay, updation hota hai, by the time you give your prelims, we'll see then. Okay, otherwise we are done. Now come towards the Earth itself. So quickly, it is also called as the blue planet. Earth is the third planet, Mercury, Venus, Earth, Mars. It is the densest planet. Its formation started 4.5 billion years ago. The formation started 4.5 billion years ago. Now, some discussions on the shape of the Earth. Discussions on the shape of the Earth. Okay. The shape of the Earth, number one, it is spherical, but not a perfect sphere. I think we all understand this. It is spherical shape, not a perfect sphere. It is called as the shape. Okay, it's called as oblate spheroid. The right phrase is, it is oblate spheroid. Something like a sphere. The word oblate means it is slightly flattened pole, bulging equator, flattened pole, bulging equator. This is the Earth shape. The poles, they have a bulge, the equator. The equator, they have a bulge, and the poles have flattening. Okay, and this is because of Earth's rotation. When something rotates, this part will swell out. This bulging is because of the centrifugal force. Okay, the poles are flattened slightly is because of Earth's rotation. और इस shape को for convenience we also call this as the geoid shape. Geoid shape मतलब है Earth like. It's called as a geoid shape. Okay, which means it is Earth-like shape. And Earth is slightly bulging at the equator and flat at the poles. Okay. Now, the second point, because of the bulge at equator and a flattening of poles, the force of gravity is relatively more at the poles and it is lesser at the equator. Okay? जितना ज्यादा डिस्टेंस होगा उतना कम ग्रेविटी है. So force of gravity is product of the mass divided by square of the radius. So if something has bulge like this, okay, so this distance is less and this distance is more. So the gravitation pull here, G is less and this pull is going to be more. I believe you all know this. Okay. So if I have a pendulum clock, okay, which clock will move faster? Okay, if I have a pendulum clock here, it can swing, and if I have a pendulum clock here and it can swing, say clock B and clock A, which one will move faster, A or B? Which will move faster? Simple thing, this is a pendulum. You have pulled it like this and released it. When the pull is more, क्या होगा? ये वापस नीचे जल्दी आएगा, right? So which moves faster? Yes. So A, this moves faster, whereas this will move, or the pendulum clock here will move slow. Okay? इसको एक तरह से और लिखते हैं. The pendulum clock at A is faster than at B. So which clock will gain time? Okay? And which clock is losing time? So a clock moving faster is gaining time. And a clock moving slower is losing time. Remember, I'm saying the clock is losing time. I'm saying the clock is gaining time. ठीक है? Which means, if a person is using the clock, घड़ी यूज कर रहा है, okay, person will lose time where? Okay, poles or the equator? Okay, which clock is losing time? Equator. Which is gaining time? Poles. So a person using the clock is losing time where? Okay, yeah, बताओ. Poles or equator? This is the catch. Okay, now listen, look at this. ये दो अलग टर्म है. the clock gaining and a person gaining, ये सेम चीज नहीं है. ओके, फॉर एग्जाम्पल अभी 8 बजा है, मुझे पेपर सबमिट करना है 9 AM. ठीक है, आई एम राइटिंग एग्जामिनेशन and I have a clock which is moving faster. Which is moving faster. क्या हो रहा है? 8 से 9 जल्दी खत्म हो रहा है कि कम खत्म हो रहा है? जल्दी खत्म हो रहा है. तो उसके the person is what? He is losing time. I hope you got the point here, all of you. And if the clock moves slowly, okay, बाकी का खत्म हो चुका है कि मेरे घड़ी में दिखा रहा है 8:45. I've gained 15 minutes more. ये दो अलग चीज है. ओके, द क्लॉक गेनिंग टाइम इज इक्वल टू अ पर्सन लूजिंग टाइम एंड ए पर्सन अ क्लॉक लूजिंग टाइम, अ क्लॉक लूजिंग टाइम इज इक्वल टू अ पर्सन गेनिंग टाइम. दिस इज द इंपॉर्टेंट कैच. और यही प्रॉब्लम होता है इन डेट एंड टाइम कैलकुलेशंस, राइट? सो बी वेरी केयरफुल हाउ द क्वेश्चन रीड्स. ओके, सो सी द क्वेश्चन विल बी मोर अप्लाइड बेस्ड. एंड जस्ट गिव एन एग्जांपल ऑफ दिस. ओके, आई विल कम बैक अगेन ऑन दिस एग्जांपल देने के लिए. इमेजिन हियर, से आई एम ऑन दिस मेरिडियन एंड से दिस इज 10 AM. If I am on this side, okay, so what happens is, this side the sun rises early. तो यहां पर अगर लोकल टाइम 10 है, तो यहां पर लोकल टाइम कितना होगा? ओके, प्रोबेबली कितना हो बताओ? If I'm here and right now my local time is 10 here. एट द सेम टाइम यहां पर कितना लोकल टाइम होगा? 10 के आगे होगा कि 10 के पीछे होगा? आगे होगा, राइट? इट प्रोबेबली इज ओके 11 AM, राइट? वी गॉट द पॉइंट हियर. अच्छा, नाउ से आई मस्ट गिव एन एग्जामिनेशन. अगेन द एग्जामिनेशन एंड्स एट 12 o'clock. इफ आई सिट हियर एंड गिव द पेपर, कितना टाइम लगा मुझे? I've taken 2 hours. But for some reason, if I've come here, how much time मेरे पास रह गया? 1 hour. So have I lost time or gained time? I have lost time. So when the time moves ahead, we lose time. Okay. If I am on this meridian, so time शायद 8 AM है. एग्जाम शुरू नहीं हुआ है आपका. आपको लग रहा था टाइम हो चुका है, अरे और 2 घंटा बचा हुआ है. आई हैव गेन्ड टाइम. दिस इज वन कॉमन मिस्टेक, कंफ्यूजन होता है इन कैलकुलेशंस. व्हेन द क्लॉक इज मूविंग अहेड, यू आर लूजिंग टाइम. व्हेन द क्लॉक इज मूविंग बिहाइंड, यू आर गेनिंग टाइम. इज दैट फाइन ऑल ऑफ यू नाउ? सो दिस वाज one of the points. So somewhere in a box, write it down here. When the clock moves ahead, okay, we lose time. When the clock moves behind, we gain time. We gain time. है ना? बच्चों को उठाने के लिए घर में आपके पापा ने किया होगा शायद, घड़ी आगे चला देते हैं, राइट? ओके, सो वन फाइन मॉर्निंग, you do not know it, घर का सारा घड़ी 15 मिनट आगे चल रहा है. Okay, that's one way of telling you time खत्म हो रहा है. Get ready fast. Okay, ठीक है. So this is done. Okay, what do I mean by gaining time, losing time? I'll come back again on some other context. Now let's get back to again the shape discussion. Okay, what are the evidences of the spherical shape of Earth? What are the evidences of spherical shape of Earth? there have been couple of questions on this. Okay, number 1, all other celestial bodies are spherical. So why should Earth be an exception? All other celestial bodies are spherical. हमने मून देखा, हमने सन देखा, we have seen Mars, we have seen the stars. I use a telescope. When all other bodies are round and spherical, why should Earth be an exception? Okay, but remember, this is an inference. This is not necessarily the conclusive evidence. 100% guarantee है वो नहीं है. This is more of an inference, but not conclusive. हो सकता है Earth is not exactly spherical. Maybe there are other planets we do not know. They are not spherical. Okay, that's one. Second evidence is the shadow. अब देखो, आप मुझे बताओ, when we have a solar eclipse, okay, किसका shadow कहां गिर रहा है? And when we have lunar eclipse, किसका shadow कहां गिर रहा है? Okay, so one by one, let us take up lunar eclipse first. Okay, what happens? Lunar eclipse आपको moon नहीं दिखाई देता है, correct? Because sun is here. Where is moon? Where is moon? If this is sun and this is earth, where is moon? Moon is here. ठीक है? How do we see moon? अगर ये sun है और ये earth है और ये moon है, so the sun's light hits the moon and comes here. I can see the moon. The sun's light hits the moon, it comes here. I can see the moon. Okay? But if sun is here, earth is here, and this is the light of the moon, of the sun, and the moon is somewhere here, तब दिखाई नहीं देगा हमें. ठीक है? Another cases, say the moon is somewhere here. Okay? तब भी दिखाई नहीं देगा, और उसमें क्या होगा? ये पार्ट शायद नहीं दिखाई देगा. So what happens in lunar eclipse is the shadow of the earth is on the moon. I hope you got the point here. So our discussion point was that when I say lunar eclipse, this is the earth between sun and moon. So this is sun, this is earth, and this is moon. Okay. So what happens is the shadow of the earth, it falls on the moon. ठीक है? ये वाला पार्ट मून का दिखाई देगा, ये वाला पार्ट मून का दिखाई देगा, बट ये पार्ट दिखाई नहीं देगा. ठीक है? So we get the earth's shadow on the moon. So can we see the shape of the earth in that case? Yes, right? Shadow क्या होगा? So lunar eclipse में we can see the shadow of the earth, and that is spherical. Okay? So lunar eclipse, the shadow of the earth is on the moon. आप बताओ, will this be a conclusive one or not a conclusive one? इसमें कोई डाउट होगा कि नहीं? इसमें डाउट है, चलो, because maybe earth is not spherical, exception है. but जब shadow गिर रहा है, will that be a conclusive one or not? It is conclusive. Shadow cannot be anything but the shape of the body. Okay, so lunar eclipse mein, okay, it is the conclusive evidence that Earth is spherical. What about solar eclipse? What about solar eclipse? This is, yes, this is the sun. The moon is between the earth and the sun. Okay, moon is between the earth and the sun. तो इसमें किसका शैडो कहां पड़ रहा है? मून का कहां पड़ रहा है? अर्थ पे पड़ रहा है, करेक्ट. Okay, and sun gets blocked. So this is the proof of shape of the moon, not of the earth. The lunar eclipse, okay, blocks the sun. Okay, so lunar eclipse is a proof of moon's spherical shape, not of the earth. But I can conclude कि भाई moon भी spherical है, sun भी है, so maybe okay, earth also is spherical, but वो indirect inference है. Okay, so which eclipse tells you what? You should be aware of that. Okay, okay. The third evidence. Online, all keeping pace with me? Online, all fine? Okay, the third one. Circumnavigation of the world. Circumnavigation of the world. Okay, that I am able to navigate the world. So I start from here, okay, and I can come back here. There's also proof of Earth is spherical. But then again, circumnavigation is not the conclusive proof. It's possible the shape of the Earth is also, say, oval shape. तब भी आप वापस आने वाले हो ना. Okay. So circumnavigation is a good shape, is more likely, but we do not say it's a conclusive shape, it's a proof. अगर irregular shape भी होगा ना, if you have a method to go around, तब भी आप आके यहीं पहुंच सकते हो. ठीक है? But it is one of the evidences कि Earth is a sphere. Circumnavigation of the globe. अच्छा, the next one. The fourth one, viewing a ship as it approaches the coast. अगर ये flat होता, I'm observing from here, I can see the full ship at one go. छोटा होगा, पास आकर बड़ा हो जाएगा. But if my surface has a curvature like this, I'm standing here, I'm seeing like this. When the ship is here, I don't see anything. Then the ship comes here. I just see the flag. The ship comes here. I can see the mast and the flag. The ship comes here. I can see the full ship completely. Okay, this is the line of sight. When a ship comes towards the harbor, we don't see the full ship completely. We see first, okay, just the flag, then the mast, then the full ship. This is what was used by Aristotle to prove that Earth is spherical. To prove that Earth is spherical. Okay? First we see the flag, Then we see the mast, जो pole है, the flag and the pole, and then we see the complete ship. But then again, people say that this is not a proof of Earth is perfectly spherical. This is more a proof of the Earth's surface is curved. Okay. But अगर यही pattern in all sides same है, okay, I see the same rate of change towards my north, towards my east, towards my west, towards my south, in all directions. तो अगर आप पानी में खड़े हो on an island and all around you is water, in all directions if I see the same pattern, then I will say Earth is perfectly spherical. Okay, so this is considered as the proof of spherical shape, but it is a better proof of Earth is curved shape. Earth is curved shape. ठीक है? अच्छा, next. The next one. Now see, you all know the pole star. What is the pole star? It is some star which is aligned along the axis of the earth. This is the earth. This is the axis of the earth. And along this axis, very, 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 very far away, कहीं पर pole star है. And the arrangement is such that the axis always points towards the pole star. This is the pole star, also called as the north star. Okay, इसका alignment ऐसा है. Now there is a very unique arrangement here where the height of the pole star, लिख लो आप, height of the pole star is always equal to the latitude of a place. The height of pole star is always equal to latitude of a place. What do I mean by, look up all of you, I'll explain some bit of geometry here. Okay, the height of the pole star is equal to latitude of a place. What do I mean by height of a star and what do I mean by latitude of a place? Online, are you all with me? Online, all with me, fine? Yeah? Yeah? Okay, fine, great. Kaushik, Abhinav, okay, Patel, Shivangi, all good here? Okay, now see, what do I mean by height of a star? If I stand horizontally, okay, and I have a horizontal plane यहाँ पर है. If I see a star, I take a vertical angle. This angle is called as the height of a star. Can you imagine here? So if I'm standing here, this is the horizontal plane and the star is here. The angle between this and this is considered as the height of a star. So mariners and ocean travel में they use an instrument called as sextant. Okay, sextant is something like this. ऐसा होगा, ऐसा एक compass जैसे होगा. Okay, they hold this vertical and they align this with the star. The angle gives them, okay, what is the height of star. ठीक है? अच्छा, next. If I say latitude of a place, say this latitude is 80 degrees. This latitude is say 60 degrees. This is say 0 degrees. This is say 40 degrees. What does latitude mean? Okay, essentially, if I consider the equator as a baseline, okay, as a place here. The angle of this place from the center of the earth and this line, this is called as latitude of a place. Okay, so 40 degree latitude का मतलब क्या है? That if I hold an angle here, you turn 40 degrees, it touches here. 60 means what? This angle is 60. 80 means what? This angle is 80. 90 means what? Okay, this angle is 90. Okay, so from the Earth's center, okay, what is the angle of a place? Okay, is the latitude of that place. Is it okay, all of you? Okay. Yeah, so what we have is, very interestingly, if this is the Earth, okay, and say this is some position, okay, and this position is a horizontal line here, and say the lines are coming from north star से आ रहा है, coming infinity. Say it comes and joins somewhere here. So if you look at this angle is equal to this angle. So observer is standing here. Okay. So it's a curved surface. No, इसको ऐसे कर दो. Okay. The curved surface. I'm standing here. This is the horizontal tangent. This is the pole star. ये angle of the star होगा ये वाला. So for this one, okay, this is the pole star का line आ रहा है. Okay, this is the horizontal tangent here. This angle is theta. ठीक है? And this place का latitude is some angle alpha. Right? Because these two angles happen to be same. It's only possible when this is a spherical shape. It's only possible if it is, okay, a spherical shape. I'm redrawing if we miss out here. This is the Earth's shape. ये एक्सिस है ये. Star is very, very far away. Very, very far away means the lines are coming parallel from the infinity. Okay. So अगर ये locations हम देख रहे हैं, okay, the star is, light is coming parallel, एकदम straight आ रहा है. It's coming and hitting this line. Observer is seeing it. So this is the line from the pole star. For this man to observe कि star का height क्या है, you must draw a tangent. So maybe I have drawn it wrong place. Just to simplify it, okay, I have drawn it here. Say observer यहाँ पर है, सोचो. Mistake I did, I put on the equator. Observer is here. Okay. So this is the vertical line, axis है ये. The rays from North Star is coming straight like this. This is the rays from the North Pole, North or Pole Star, sorry. Rays from the Pole Star. And this tangent is the horizontal line of this place. Do you understand that this is going to be the angle of the star? What I am saying is that latitude of this place, this is the latitude of the place. ये latitude है जगह का. This angle is alpha. अगर ये दोनों same है, it's only possible if the shape is a sphere, is a circle. How ये अगर अल्फा है, this angle is 90 minus alpha. If you know the properties of parallel lines, then this angle and this angle मिला के होगा 180 डिग्रीज. अगर ये 90 माइनस अल्फा है तो ये पूरा जो होगा, ओके, इट विल बी 180 माइनस 90 माइनस अल्फा. दिस विल बी 90 प्लस अल्फा. ये पूरा एंगल, दिस एंटायर एंगल. अगर ये 90 प्लस अल्फा है एंड दिस एंगल इज 90, ये कितना बचा? अल्फा. तो थीटा इज इक्वल टू अल्फा. Yes, so you don't have to calculate all of that, but just know this. For some of you curious minds, essentially these two lines are parallel. जब भी हो सकता है ये. So our point is that one of the proof that Earth is spherical is that the height of the North Star is, okay, equal to the latitude of the place. This was our point. One of the important conclusive proofs is the height of the pole star is equal to the latitude of a place. Latitude of a place. ठीक है, and this also is conclusive. So conclusive में हमारे पास दो है. One is the lunar eclipse is conclusive. And the pole star angle, okay, matching the latitude is also conclusive proof. Next, miscellaneous aspects about Earth shape. Miscellaneous facts about Earth's shape. So लिखा दिया already मैंने. It is actually geoid shape. The gravity force is not same, or it is more at the poles and equator, more at the poles and equator. Okay. Third, now look at this. If this is a sphere like this, and I'm drawing latitudes, I hope you know latitudes are parallel lines. Sorry. Latitudes are parallel lines. Now what happens is the distance between latitudes is same. The distance here is same. But if the flattening happens, so ये ऐसे गोल नहीं होकर the flattening happens and it starts becoming this. Flattening हो गया ये वाला. So what will happen? Distance between latitudes. Okay. Will it be more or less? It will become more. So this length was when it is spherical. अगर flatten हो जाएगा, this length will become more. Okay? If Earth was perfectly spherical, then the distance between latitudes will be same in terms of linear distance. Generally we say 1 degree latitude is equal to approximately 111 kilometer. The distance between 1 degree, this is say 0 degree, this is 1 degree, this is say 2 degree, this is the 3 degree. Okay, the distance between them has to be 1 kilometers. Because flattening हो रहा है, polewards, the distance between latitudes increases. Because there is flattening, लिख लो आप, because there is flattening towards the poles, the distance between latitudes increases towards the poles. Otherwise, if it was spherical, then the distance between latitudes would have been, one latitude would have been this much, and that's equal to approximately 69 miles. The distance between 1 degree latitudes, agar spherical hota, it would have been 1 kilometers or it would have been 69 miles. Okay? Because of flattening, the distance between latitudes towards the poles increases. The distance between latitudes towards the poles increases. And the last point is, you know that now, that clocks gain time towards the poles, or clocks move faster towards the poles. They move faster towards the poles. Okay, fine, all of you. That's for today. They continue tomorrow. Geography students, because we had this information morning mein that we'll have power cut, so we have cancelled geography's class today. Okay, those are an optional class. You guys can sit and do the, in fact, abhi bhi kuch der pehle we're running on the inverter. So you guys can do your synopsis work and finish off. And those who must submit your assignments. Tomorrow I'll continue with this. I'll finish off the dateline discussions and move towards some discussions on the features of the earth, the interiors, the geological timescale and the rest. Okay. All of you, thank you for being patient. Have a nice day. Offline अगर बैठें तो बैठ के खत्म कर लो. If you can, take a break of 5-10 minutes and finish off. Okay. Bye all of you.